does. A lot of times. Do you understand what her question is?
Yeah.
Yeah.
Here's her question, which was a very good question that I'm glad you're asking.
Access.
Here's a trap that a lot of paramedics get into. I don't ever want you to get into this trap. Break the habit now. A lot of paramedics, when talking about bundle branch blocks, like to discuss rabbit ears. They like to talk about rabbit ears because it's fun to say. Hey, look, they've got rabbit ears. Look, hey, do you see some rabbit ears here? They talk about rabbit ears. Rabbit ears is a way to denote, and we do talk about that, it's a way of noting that there's a peak and a peak, right? Two peaks that create the rabbit ears, which is an RSR pattern. Does that make sense? Okay. The problem that we have with paramedics always looking for rabbit ears, which means paramedics get into the habit of seeing a wide QS complex, they're trying to side it left or right, so they go straight to V1 and they look for rabbit ears. I've asked you to do what first? Where have I asked you to look first?
V6.
In V6 and for what? For the slurred S waves. The problem that we get into when you get keyed in on those rabbit ears is exactly what Amanda's asking about. Why she's asking, wait a minute here. If I'm looking at if I've got V1 and V1 is here, looking at the right side, then isn't all of this stuff that's firing away from V1? So shouldn't V1 actually be negative, not positive? Do you understand her question now?
Yes.
And in fact, it is a lot. In fact, when you look at V1 on a monitor and it's normal, what should the QRS complex be in V1? It's a negative QRS complex. We haven't seen a lot of 12 leads yet, but you're going to start to see a whole bunch of them, and it has a little tiny R wave with a big giant S wave. Normally. So the question is, if I'm in V1, shouldn't all of that be negative? And the answer is a lot of times it is. A lot of times it is. In which case, what we end up getting, instead of an RSR pattern, we get a QR pattern. And we actually call it QR prime in this case. We call it that because we know that that Q wave is actually not a pathologic Q wave. It's an actual R wave for the left ventricle. That makes sense? So we sometimes see a QR or QR prime pattern on that left side when we have a right bundle branch block.
What's the difference between that QR prime and QR prime?
These two?
Yeah.
What's the difference? Somebody to draw it. Please draw me one of each of those right behind you on the pen. Turn around, grab a pen. Turn around, grab a pen. I know you are.
He's going to
Tell me what you think you need to draw there. What would a QR be and a QR be? Anyone can help him.
It's a big Q wave and then a
Yeah.
small Q wave.
Big Q, big R, small Q,
So-
big R.
Yes.
Did y'all hear that?
Big Q, big R. And this is a little Q, little big R.
That makes sense? Do y'all remember our nomenclature? So whether or not it's a capital letter or a lowercase letter tells us the relative size within that QRS complex.
There's no measurement, it's just like, that one looks quite a bit bigger than.
Yeah, there isn't an exact measurement. It's a way of being able to, in a written way, say this is roughly what I've seen. Right? We good there? So what that means is our rabbit ears sometimes have an ear down.
Oh.
Wait, so is this only in lead 1 and 6?
We're looking in V1. V1.
So, okay, yeah, sorry.
V1.
V1 and V6.
No.
V1.
V1.
Just
That's the
V1.
only one we're looking at right now.
Okay, so if you see that on V2, this looks normal though, right?
Say that again.
Because what I'm confused about is, yeah, there is a Q and an R, but when can you differentiate whether or not it's just a regular R?
A regular.
What? I'm gonna throw this question back at you.
I can't.
V1 looks where? V1 is located where?
Right. Ventricle, anterior,
So right here,
yes.
right? That's where V1 is. Forget bundle branch blocks. We're just talking about normal depolarization. Just normal depolarization. When the QRS complex is firing and the ventricles are firing, where is the majority of all the electrical activity? The left side. If and the left side is firing this way and posteriorly, primarily. That's the way the left side fires, right? So what's the QRS complex normally going to look like in V1, where my finger is?
Smaller. More negative?
Yeah, because everything is firing away from it.
Yes.
The majority of my electrical activity is firing away from it. I see a little tiny bit that comes, I see a little tiny bit of the septum, right, that fires, and the start of the right side that fires. So I see a little tiny bit of the septum and the right side that fires, which is going directly at V1, right, because V1's right there. But then the majority of the electrical activity is firing where compared to V1?
I don't know where.
Away from it. So that's what my V1 normally looks like. Does that make sense? So the fact that I have a positive R wave in V1 all on its own tells me there's a problem. Because it shouldn't be positive. I should have a negative QRS complex in V1. Right? I should have that. Now what's happening is my right side is firing later than it's supposed to and longer than it's supposed to. But because my right side is firing later than it's supposed to and longer than it's supposed to, that means the very first thing that V1 sees is the left side firing, because the right side's not firing yet. Does that make sense? If the left side is the first thing that's firing, typically, what direction does the left side fire compared to V1? Away.
So how would you get the linear sign if it's?
Because it just depends on where anatomically the axis is of that heart. So sometimes that axis is more, the firing is more lateral and anterior in some people than posterior. And so V1 in that case would see a positive R wave. But what would its size be?
Small.
Pretty small compared to what it's going to see on the right side. Does that make sense?
Yeah.
Good. So that's my left side firing. And then right after that, my right side starts to fire. But the left side's done firing. So the only thing left to fire is the right side. So the only thing that V1 is looking at is the right side. So it's a huge R wave because it's all coming directly at it and it's taking more time because it's going cell to cell.
If it's going cell to cell and it's not going through the Purkinje fibers, correct? How come it's pointy and not more rounded?
It sometimes is a little bit more rounded. The reason why the right side tends to be more pointed than rounded is because there's less cells firing, so therefore they do fire fairly close together anyway. But it does widen out a little bit. But most of that widening out is happening on average all the way through it, which is going to be very different than what I'm going to show you next. But that's just because of numbers of cells. Even though it's going cell to cell, it's still a small number of cells compared to the left side. So the trap that paramedics can sometimes get into is they're always looking for this pattern. In V1, they're always looking for this pattern. But sometimes we don't see that pattern. Sometimes we see that pattern instead. In fact, a lot of times we see this pattern instead. So, or we see it mixed up where you might have something like this, where you barely see anything at all.
But you notice the QRS is wide.
But the QRS is wide first.
Would you
So-
notice negative deflection bunny ears?
Say again.
Would you notice instead of having both positive, your R and your R prime being positive deflection, would you have an R and R or a
Q.
negative deflection?
Q
You're looking
and Q and Q prime.
Little trough.
As in, would you have something like this?
You could have that in.
Is that what you're asking?
V1.
Not in V1.
Not in V1.
Because V1, you'd have to have heart muscle that is really winked out.
Yeah,
Because V1 is looking directly at that right side.
they have to be firing away, which means it's.
There's not muscle mass, the right side doesn't have muscle mass that goes all the way around, like the left side does.
Okay.
Right, the right side, my hand would be the right side. My hand and my left is the left ventricle. The right side, literally, when it contracts, it just, that's all it does. Right? The left side is this big giant figure eight coming from the apex, squeezing like a rag, all kinds of stuff to get the blood flow out. But the right side just goes, and it's done. That's all it does. It only has to generate 20 millimeters of pressure, right? It's nothing. So for the V1 to show you where my that is, for V1 to be able to do something like that, either the heart would have to be rotated, or you'd have to have something terrible going on with the muscle mass there for that to happen in V1.
And you would anticipate, like, for hypothetically, if you had dual troughs, you wouldn't have instead of going from endo to exo, you go from exo to endo?
I mean, that would be a possibility.
Okay.
It's not gonna happen, but.
Okay.
Now, I'm not saying that you can't ever see this in V1. I'm saying you can't see it in V1
For it to be right.
with the right side button wrench block.
You
Could be a left.
You could
Yeah,
see it
for
in
right
V6
side.
Yeah.
or
Okay, I get
V1.
You might see something like that in V1 because there's something funky going on with the left side.
Especially if it's a lap or a posterior block.
You might see something that, but
Okay.
not for this right side.
Okay.
Okay.
So if we see that in V1, it's not right side almost.
If you see that in V1,
Statistically, it's not gonna be.
it can't.
Okay.
So your criteria that you're looking for is that you have a supraventricular rhythm with a wide QRS. You look for slurred S waves in leads 1 and V6. If you see slurred S waves in 1 and V6, then you look for either an RSR pattern or a QR prime pattern in V1. You have all of this criteria. If you do not have all of this criteria, but you have some of the criteria, then we travel down a different path, IBCD, which we haven't talked about yet. So you either have all of this criteria and it's a right bundle branch block, or you have not all of this criteria and it's not a right bundle branch block. Does that make sense?
All or nothing.
It's all or nothing on that. Good? The S waves can be all kinds of different things. This makes it really hard, and I know that it makes it hard. Deal with it. Paramedicine's not easy. It might be hard. Your S waves could look many different things. If it's one of these patterns, it can be weird and funky because you're going, okay, wait a minute. Is this my J point? And is this my ST segment? Right? But in fact, this is actually my S wave in this one. But this might look exactly like what a QRS complex looks like when you have ST depression also. So, what do you do?
Look
Do
at
you
the
rule
leads.
that out by looking in reciprocal leads for
For what?
ST elevation?
Okay, I want to change your thought process. You never, so ST depression will never show you reciprocal ST elevation.
Okay, yeah.
ST elevation might show you reciprocal ST depression. We haven't talked about that yet, but
Wait,
that's important.
say that again. You cannot have ST depression, you cannot have ST elevation in a reciprocal lead if you see ST depression. But if you see
ST
ST,
ST depression does not cause elevation, but elevation causes
Exactly.
depression.
ST depression will never cause a reciprocal ST elevation. ST elevation can cause a reciprocal ST depression.
depending on the lead though.
Doesn't matter what the lead is. I need you to make sure that you are understanding that concept, right? If I see a lead If I see a lead that has ST depression, and I look in its reciprocal, we've not discussed reciprocals yet, relax. But if I were to look in its reciprocal and see an ST elevation, this is not the reciprocal lead. This is. Just because I looked at it first does not mean it's reciprocal.
Okay.
Does that make sense? This is the main lead, that's my reciprocal lead. If I see this in the reciprocal lead, meaning I don't see elevation, then I can go back to this lead as the primary lead and say I've got ischemia. Does that make sense? Is that clear?
Yeah.
Okay. The way of saying that is really important to make sure that you are keying in on. You will never have reciprocal ST elevation. You can only have reciprocal ST depression. That being said, you can look in other leads, but you don't need to look in a reciprocal lead. Because all you need to know is you need to look in a lead that doesn't have a funky thing down here where you can get a clear measurement of the QRS complex. Because if I have a wide QRS complex in this lead, what is my QRS complex in every other lead?
Wide.
So I can just find a different QRS complex that doesn't show a funky little step right there, right? And I can take that measurement and then transfer that measurement to here and go, that's where it has to end. Does that make sense? So you might have to investigate a little bit to tell that leads 1 and V6 are showing you a slurred S wave by looking in a different lead, right? To get the measurement and then to compare it. That's a possibility. I'm not going to say it's easy. It can be frustrating and difficult to tell, right? And in fact, you need to make sure that you weren't calling this ST depression because it's not, right? Does that make sense? The S waves can have a lot of different looks to them.
It's a slurred S wave.
Yeah, this ends up being a slurred S wave.
That's what we would call it.
Correct. Does that make sense? Okay. The RSR patterns can be weird and abundant, just depending on what I talked about before, how often the signal gets into autorhythmic cells and out of autorhythmic cells. So you might start to see multiple types of patterns on the R waves, but in a right bundle branch block, all of the R waves that are related to the left side are tiny. The largest one is going to be the right-sided one, and it'll be the last one, whatever it is. But you might see tiny little bumps, or you might see something, if you see something like this, I realize that is extremely subtle, but what should the slope be from baseline to point? Straight. You see that it's not straight right here. It went up straight, it went up straight, and then it changed its slope. Does that make sense? Even though that's not showing you a clear bump, that is still an R wave right there. And this is my R prime.
You know it's not artifact because you'll see it continuously?
Because you'll see it in other ones as well. And I don't see any evidence of artifact anywhere else. That's right. But I'll have to look at that, right? Does that make sense? So it can be extremely subtle, or it can be very distinct. It doesn't matter whether it's subtle or distinct, right? Question?
It's not about the QRS.
Any questions about the QRS? Ask your questions.
Okay. How the heck are you able to tell the difference for where your P wave is on that? Because that could be an inverted P wave, or why isn't that little R nub right there a hidden P wave?
That is a P wave. It is inverted.
So that's a junction.
What the heck? How did you know?
What lead are we looking in?
One.
What lead are we looking in?
V1.
V1. What should the P wave be in V1? It should be negative.
Okay, just because it should be negative, doesn't mean it is.
V1's right here. Right? V1's right here.
Not necessarily.
The electrical activity of the atria, right, is traveling that way compared to V1.
Will you hold your heart again?
As in this way.
So here's my V1. The left atria is clear over here, and all the electrical activity is traveling that direction, which is away from V1. So the P wave should be negative in V1.
And your T wave should be inverted.
And oftentimes the T wave is too. Yep. Not always, but sometimes.
Why is your R wave thing, how are you confident that that is not a hidden P wave?
Because my P waves are there. If
I
that's,
know, but what if you got a heart block going, what if you got
if that
a
were,
pin?
if that were a P wave, first of all, it wouldn't be as peaked as it is. Second of all, it would take more time. And if it were tucked into the QRS, like for example, a junctional rhythm,
Yeah,
if it were a junctional rhythm, then I wouldn't be able to see the peak on it. It would be mixed into the QRS because it can't finish in that much time. It has to take more time than that,
got it.
because the P wave does take more time than that.
Would a junctional rhythm in V1 be positive? Would the P wave and a junctional rhythm
A lot of times,
in V1 be positive?
yeah, a lot of times it is. Yep. Good? And so that's an R wave. Followed up by this wave,
Got it.
followed by an R prime and an R double prime.
And you're counting that little wave out to make sure it's on pathologic? The R and the S?
Right here,
Yeah,
well, this is not a third the height of the R wave,
so you're like,
and there's no white space in there, which means it's not greater than 0.03 seconds, so that's not pathologic. And that's an S wave anyway, not a Q wave.
so are you gonna go through that reasoning every time to ensure that it sounded?
Of course. But I know it's an S wave because it comes after the R, so it's not a Q wave, so I don't have to worry about it at all.
Oh, okay.
And even if it was a Q wave, it doesn't meet any of the criteria to be pathologic.
God, now you're worried just because it looks bananas.
Good?
Bananas?
Again, sometimes you might have the Q wave in a bundle branch block because the left ventricle is still firing normally. And the left ventricle is firing away from the right ventricle for the most part. So, your criteria number one, what kind of rhythm do you have to have?
SVT.
Supraventricular. What do you have to have next?
Ventricular tachycardia.
Wide QRS. Where do you look next?
V6.
Where do you look next?
V6 and lead one.
V6 and lead one. You guys have to be extraordinarily careful about saying lead one and V1. They are not the same
It's
leads.
confusing.
They're not the same leads. So where am I looking next?
1 and V6.
Lead one and V6, and I'm looking for what?
Slurred S wave.
Slurred S waves. And then after I see the slurred S waves, I look where? V1, and I'm looking for what? RSR or a QR pattern. An RSR or a QR pattern in V1. If I have all of that criteria met, then I can say this patient has what?
Right bundle branch block.
A right bundle branch block. So, slurred S waves in 1 and V6 in the context of a wide QRS and an RSR or QR pattern in V1 is what I'm looking for.
So just for clarification on V1, would we also potentially see you don't want us to get caught up on bunny ears, because it doesn't always show it that way. The one slide that you showed a little bit earlier, we're gonna have potentially a negative and then a positive.
It's the QR
So with that, you
QR.
have a slurred in 1 and a slurred in 6 and a negative and a positive in V1?
Of course.
Okay.
Yep. Quite commonly.
So more commonly that we
No,
see that?
not necessarily more, but commonly. Commonly enough that I don't want you to get caught up on
Bunny ears.
the bunny ear comment that all paramedics like to talk about, because it gets you screwed up. I want you to key in the context of a wide QRS, in a supraventricular rhythm, I want you to key in on leads 1 and V6 first. Look for those slurred S waves first.
Okay.
And then after you look at those slurred S waves, then you can start to look at V1. Does that make sense? Okay, in your packets, the printers screwed up and just didn't make the bundle branch part blue, so you gotta find it. So it's after the axis, and after the axis, 12 leads. That's the last axis 12 lead that I'm showing you right there. And this paper that has writing on it starts the bundle branch block section. And I want you to find that section for a moment. It's before MIs and after axis.
There it is.
Keep going, keep going,
Keep going.
keep going.
254.
Good? Do you see it? You should have a page that at the top says bundle branch blocks.
There's no consistent numbers. Keep going.
You have a page that says bundle branch blocks. Yes? After you find the page that says bundle branch blocks and has a bunch of writing on it, turn the page and look at the very first one, number 1 of the bundle branch blocks. Is that rhythm supraventricular?
Yes.
Does it have a wide QRS complex?
Yes.
I know that they're a little bit hard to tell, but figured out.
Oh, it's in the bundle block.
Does it have a wide QRS complex?
Yes.
Which QRS complex would you have to look at to be able to tell that?
1 and V6.
Well, one's got a slur.
Any of them. Because it's all the same. It doesn't matter which one you look at.
For wide width.
You just have to find one that shows you a clear width. So you
Right.
find out that it's a wide QRS complex. Where do I look next? 1 and V6. What do you notice in 1 and V6?
We have
It is wider
slurred,
than-
slurred.
The S
S
wave is
wave.
wider than the Q.
Do you see a slurred S wave there?
Yes. You're drunk.
Look
Go
at
home.
V1. What do you see in V1?
QR.
You have a rabbit ear, a floppity.
You have
A deviated R
okay,
wave,
so Noah
kind
says
of.
you have a small R, big Q, large R, and I disagree with him. What do you have?
You have RS.
You have an RSR.
RSR.
Because why is it
RS.
not a Q, Noah?
Oh, there's a little uppity up right there.
First negative.
Good. So we have an RS R prime pattern in V1. Does it meet the criteria for a right bundle branch block?
Yeah.
Yeah.
Isn't that cool? Then we have it.
Good job, guys.
Just for kicks, look at number 5.
Okay.
Look at number 5. Do we have a supraventricular rhythm?
Yeah.
Do we have a wide QRS?
Yes.
What lead do you see that in?
All of them.
Look in what leads next?
1.
Do you see slurred S waves in 1 and V6?
Yes.
Where do you look next?
V1.
V1. Do we have an RSR or R or QR pattern there?
It's a weird one.
It's really hard to see.
V2 does though.
Well, what else could you do? What did
V2.
Dustin just say? What does V2
V2.
show you?
Rabbit ear.
Yeah,
RSR.
RSR pattern. And if you look at that and then go back to V1, you will actually notice right at the tip a very slight change, and very subtle because it's hard to see on this in the ink, the way the ink's written. You'll see a slight change in the slope.
Does it have like a 3-peak almost go to it?
It doesn't. But you'll see a very slight change
No.
in the peak.
Not 30, it's like.
Well, this is also right bundle branch front.
So this is also a right button. Isn't that great? Hey, look at number 7, just for fun.
Just for
fun.
funsies.
Do we have a supraventricular rhythm in number 7?
Yes.
Yeah,
Is it a wide QRS?
yeah.
Yes.
Which lead doesn't show you the wide QRS?
None of them.
None of them, because they're wide in all of them, aren't they? Fan, what do you
Well-
look at next?
What about AVF?
It's too biphasic to tell.
But it doesn't show it.
Yeah, so the
Well,
question
it
is,
kinda,
the question
like,
is,
my eyes aren't
Sarah asked
good
a
enough
really
to-
good question. Look at AVF. That's a really small biphasic lead. Oh, hey, just because I think we might as well talk about it, AVF is really biphasic. Where's the axis of this heart? Where's the axis of this heart if AVF is biphasic?
0,
0,
1.
0 or 180, right? So if it's at,
One.
if we think that it's
Zero.
going towards
0.
0, then what should lead 1 be?
Positive.
How positive?
Super
Completely.
Is it?
The most
Yeah.
positive.
Wow. Oh my gosh, this stuff almost makes sense. Okay, so we're going back to leads 1 and, so we're going back to Sarah's question, which is, well, AVF really doesn't show me that it's really wide, does it? Is it wide in AVF?
Most likely, I just can't see it.
You just can't see it. Because in a biphasic lead, our options for biphasicness is equal up and down or what?
Nothing.
Or nothing, and you might have a combination within that lead. So your biphasic lead will always not be a good lead to look in to try to give accurate measurements. So we're looking at leads 1 and V6. What do we notice?
Slurred S wave. Go
A slurred
figure.
S wave. Where do we look next?
V1.
In V1. And what do we see in V1? What do we
RSR.
see?
RSRR.
There's 3 R's.
R,
RSRR.
R prime. So R, S, R prime.
And then slurred S.
R double. How do you write R double prime?
2 lines.
With 2 primes.
Just 2 slashes?
Yeah.
Okay.
So when you're talking R, S, R prime, R double prime, is the first R small?
The first R is small.
The second R is,
The R prime is small.
the R.
The R double prime is, so we would be writing this. So in this one, right, here's what you have. You have this, right? Right? Is that roughly what we have?
Yeah.
So in this one, we would have an R, S, R prime, R double prime.
You think the second R is small?
That second R is small, yes.
So, what's the difference again?
It's
between
barely
a
above
big
baseline.
Lowercase r and uppercase r?
What's the difference between our lower cases and upper cases?
Relative size.
Relative size. Relative size.
Because you can almost see
The
the
second R, we're saying is a small r because it's not as big.
relative to the
That is correct.
relative to
That-
the
that
big
R,
R.
this R right here is not very big.
So imagine if you took that exact same thing, but brought it down like one box and back up, it'd still be a small R.
Okay.
Where this just doesn't have any downward flexion to it at all. So it's still a small R. All right?
I didn't hear anything.
Your pictures were beautiful.
Incorrect.
You guys both looked like movie stars.
Okay.
And Mons too, but like you two especially. Yeah.
So let's look at the left side.
You were too. Just not as exciting.
Okay, great.
If you'd worn a gown, yes. But like their gowns, your gowns are beautiful.